Friction. Friction is in addition to the three basic forces that we introduced: weight, tension, normal force. Friction can come in as kinetic friction. It can be static friction. And there's a special case, that's what we call maximum static friction. Kinetic friction, the word kinetic means motion. So when an object is in motion, then the force that resists the relative sliding of the surfaces is called kinetic friction. In magnitude, it equals to the friction coefficient multiplied by the normal force. So here is kinetic friction. An example, if a man is dragging a box across the ground, then the friction, the man drags the box towards the left. So the friction resists the relative motion of the box with respect to the ground. So the friction is opposite the direction of the motion. So here in the red color arrow, and so F2 represent the friction acting on the box. Another example is friction for the man. So here is the man dragging the box. The man his shoes tend to slide backwards because he's dragging the box. And therefore, it is the friction force that resists the tendency for his shoes to slide back. So therefore, the static friction actually points forward. If his shoes has good gripping with the ground, then he can stand and actually drag the box. If in case he stands on ice that provides no friction, then when he pulls the box, he tends to move towards the box because the ice does not provide the static friction as shown here in this picture. So this is static friction. In general, the friction for, if you pull a box or object on the surface, the static friction force will keep increasing until at one particular point, we call it the breakaway point. At this point, the object will start to move. And at this point, the friction force is the largest. That's what we call the maximum static friction. After this, after it starts to move, the friction actually quickly reduces to what's called the kinetic friction. So static friction coefficient is always a little bit larger than the kinetic friction coefficient. Here's an example of Einstein not sliding. So that's a static friction. So the forces on Einstein, always check the three basic forces: weight, normal force. There's no strain, so there's no tension. Okay, so because Einstein is on the slope, he has a tendency to slide down. Imagine if there's no friction. If he is entirely on a frictionless surface, say ice, then he would slide down. But since he's not sliding down, there must be a friction force, as indicated by the yellow color arrow, that's holding him from sliding relatively. So this is the force that resists the tendency to move. So this is an example of static friction. If we keep raising the angle until suddenly Einstein starts to move, so at exactly that short moment when he goes from not moving to moving, that's when the friction is the maximum static friction. So here's another example. An object, if you pull it with a force, if it's not moving, that's because the friction force is resisting the tendency for it to slide with reference to the surface. If you increase the force to pull it and it's still not moving, that's because the force that resists the relative motion increased. The friction is larger. If you keep increasing more until at one point, it suddenly start to move. So that moment, that friction is called the maximum static friction. As soon as it starts to move though, the friction reduces to static friction, and that's how it moves forward. Okay, so the static friction, the maximum static friction, mean the top of the peak, equals to in magnitude the friction coefficient of static friction multiplied by the normal force. In summary, we learned about kinetic friction when it's in motion. Fk equals to the kinetic friction coefficient multiplied by the normal force. Static friction, that holds the object, and the magnitude equals to the magnitude needed to hold the object so that it does not move. Maximum static friction is at the moment when the object starts to move. So that equals to the static friction coefficient multiplied by the normal force.